Okay, our main focus for today is to discuss domain and range of a function. But before we do that, we need to discuss what a relation is and what a function itself is. So a relation is any set of points on the Cartesian plane or the xy axes. So in other words, any set of points. So perhaps we have a set of points forming a circle. Okay, that's one example of a relation. We can have a set of points forming a line. That's another example of a relation. Perhaps we have a set of points forming a parabola. Another example of a relation. Now, a function, this is a special type of relation. So this is a relation in which for each x value there is exactly one y value. So this should be review from last year. Recall that we use something called the vertical line test. The vertical line test, and we can abbreviate this VLT, to graphically test if a relation is a function. So in other words, if we go back up here with my circle, if I were to draw a vertical line, notice that it is hitting in more than one spot. So for this particular x value, there are two y's. So that is not a function. However, if I were to look at this graph, if I were to draw a series of vertical lines, or this one over here, notice it is only hitting it in one spot. So that makes it a function. Now when we talk about functions, there are three symbols that you're typically going to see used. Sometimes we're going to use y equals to represent our function. Most of the time you're going to see f of x equals. And popular with IB is this notation. So you have f and then you see colon and then x is mapped to x. I'm never going to ask you to write that notation. However, if you see it, just recognize that it really means f of x. Okay? Again, that tends to be popular with IB. So let's move into domain and range. First, domain. The domain of a function is the possible x values that a function can take on. It's the possible input for the function. Okay? In other words, it represents all the numbers that you can put in for x and get something out for y. Now, if we're looking to visualize domain by means of a graph, we're looking for where the curve stretches from left to right. Since x runs horizontally, since the x-axis is horizontal, if the domain represents our x values, it should make sense that we're looking at it from left to right. The range, on the other hand, this deals with possible y values that a function can take on. It's the possible output. So the domain is the input. That's what we can put into the function. The range is the possible output for the function. In other words, it represents all the numbers you can get for y when something is put in for x. Now graphically, if we're looking at a curve, if we're trying to find our range, we're looking for where the curve stretches from the bottom to the top. Since the y-axis is vertical, it should make sense to you that if we're trying to find range, we're looking at from where it stretches from the bottom to the top. So we have some examples here of some graphs that are drawn for us. And our task with these examples is to simply find the domain and range. Now, I've given you these graphs. We don't necessarily know what the equation is. Sometimes you'll be given the equation only. If you are allowed to use your graphing calculator, it's in your best interest to graph it. Make sure you set up an appropriate window so you can see the whole thing. and to find your domain and range graphically. And most of the time you're going to be allowed to use a calculator if you're asked to find the domain and range. So with our first example here, we are given part of a line. Now this right here is kind of hard to see. That is the point -5, comma, +5, just to be clear there. So our domain, we said, is the possible x values. Now remember, our x-axis runs horizontal. There's x, here's -x. So notice that this function, we have a closed point here at the end, and it's moving to the right forever. The arrow on the right, of course, means it's going that direction forever. But it stops right here. It doesn't go to the left beyond that point. So our domain, it looks like, remember, domain is possible x values. It looks like the possible x values are everything greater than or equal to -5. So we can simply write out x is greater than or equal to -5. There is nothing smaller than -5, so that is not part of our domain. And by the way, that's set builder notation. The other way you can write this out is to use what's called interval notation. The smallest value it could take on is -5. Since we want to include -5, we would put a square bracket around it, comma, and then infinity with a rounded parenthesis. That indicates that its x is greater than or equal to -5, including that -5, of course. So the square bracket means we're including that number. The range, well, we said these are possible y values. It looks like the y values that it takes on is everything less than or equal to 5. Right here at this top point, you can see that the highest that it reaches is 5. So our range is y values less than or equal to 5. Or if we wanted to use interval notation, we want to always start from the bottom and work our way up. So in other words, from least to greatest, it's coming from -infinity. That's what this arrow right here means. It's going down forever. And it's going to go all the way up to +5, including +5. So we would want to put a round, or a square bracket rather, around that 5. Let's move on to our next example. And let's assume here that with this graph we have arrows on the ends. So we'll just pretend it's given to us. So we have some sort of an absolute value function here. Our domain, notice it stretches to the left forever, it stretches to the right forever. So here our domain is all reals. So that capital R looking symbol, that's our symbol for all reals. Or if you wanted to use interval notation, -infinity to +infinity. That's how we say it takes on all real numbers. There's nothing x can't be. Now the range, the possible y values, it looks like it bottoms out right here at -2. Okay, that's the smallest value it takes on. So, and then it goes up from there. So again, since range corresponds to y, we're going to use the variable y is greater than or equal to -2. That's one way you could write it. Or, if you like interval notation, it's taking on all values from -2 to infinity. Okay? Let's move on to our next page. Okay, our first example here. This is a rather odd looking function. So notice we do not have arrows on the ends. We have a closed circle right there, and then we have an open circle on the other end. So the domain, again, this corresponds to possible x values. It looks like on this side, it goes all the way over to -5, and then it takes on possible values all the way to +5, but that open circle indicates that we're not including +5. So our possible x values are between -5, including -5, and +5, but not including that +5. So this is one way of saying that our domain could take on any x value between -5 and +5, including the negative 5, but not including the positive 5. And again, it's based on the fact that the closed circle means it's included, open circle not included. The other way that you could express this, interval notation. So we said the square bracket includes that number. If we don't want to include the number, which is the case with the positive 5, we're going to use a rounded parenthesis. Okay? You may find interval notation a bit easier. Okay, the range. Well, the range, the possible y values, looks like the lowest it goes here is 0. And then it rises all the way up. Now the highest that it goes is where we have this open circle, which appears to be at 1, 2, 3, 4, 5, 6. But it's not including that 6. So it starts off at 0, including that 0. We're talking about y, so we're going to use our y as our variable. And it goes all the way up to 6, but not including that 6. So that's one way of expressing our range. Or, if you would prefer to use interval notation, from 0 to positive 6, including the 0 but not including the positive 6. Okay. One more. Now, this is a rather complicated function, and we'll learn more about these functions later in the unit. But let's talk about what's going on here where you see these dotted lines. We have what are called asymptotes. Asymptotes are boundary lines that the curves are approaching on the extreme ends but never hitting. So right here we have a horizontal asymptote, and over here we have a vertical asymptote and another one at x equals 2. So at x equals negative 2, positive 2, we have vertical asymptotes, which we abbreviate VAs, and then we have horizontal asymptotes at y equals 3. So our domain, again, we're talking about possible x values here. Looks like it takes on values from negative infinity, and then it gets really close to negative 2. Same thing up here, really close to negative 2, but it's never taking on the value of negative 2. Then it goes all the way to positive 2, but again, it's not hitting positive 2. And then it goes all the way to infinity. So it looks like the domain is everything except for negative 2 and positive 2. So sometimes it's easier to write out domain in terms of what it can't be. So far in our examples, we've written out domain in terms of what x could be. So in this situation, let's go with the fact that it's all reals, with the exception of plus or minus 2. So we're saying here that the domain, the possible x values, are all real numbers, but x cannot equal plus or minus 2. Okay? Or another way of saying that, you could say negative infinity to negative 2, but not including negative 2. From negative 2 to positive 2, not including either of those. And then from positive 2 to infinity. Excuse me. So that's using interval notation. That's an alternative way of expressing our range. Okay? So again, it might make a little more sense to just say it's everything except for the 2 and the negative 2. Lastly, our range. Well, with our range here, you can see it's coming up from negative infinity on each side, and then it's kind of leveling out here at 3. So it's not going to take on a y value of 3. All right, and then up here, it looks like it's values from 6 up to infinity. So we can say that y is less than 3, but we're not including the 3. And then up top here, y is greater than or equal to 6. Okay, so that's one way to express it. Okay, or from negative infinity up to 3, but not including the 3, so rounded parenthesis. Again, that horizontal asymptote means it's leveling out there. It's not going to approach it on the extreme ends. And then from 6 to infinity, but we are including the 6 since I see a closed circle here. Okay, it's including that 6. And it's going up forever to infinity. Okay, so that's domain and range given the graphs. And again, if you don't have a graph, if you're given the equation, graph it in your calculator, take a look at it, and use your knowledge of domain being left to right, range being bottom to top.